Hey, welcome back to Mr. P Helps with Algebra. This is Unit 3, Topic 1, Lesson 3. We're going to do shape, center, and spread again, but more importantly, we are going to be doing some investigation of data displays. And as you can clearly see, we're going to be doing analyzing some box plots and some histograms, and also some line plots here, which is another name for a bar graph, basically. All right, so getting back to the warm-up, we're going to talk about what would skewed left look like. So this is skewed left. Remember, a skewed left means that the tail goes out to the left and most of the majority of the data is on the right-hand side. Skewed right is when most of the data is on the left-hand side. So it's kind of opposite of what you would think it is. And then a normal distribution, otherwise known as a bell-shaped curve, is like when most of the data is in the middle and then there's equally amount of high numbers as there are lower numbers. So histogram. So I'm just going to give a crude crude example here. So let's say 0 to 5 is the interval here, and then it goes from 5 to 10, and then it goes from 10 to 15, and then 15 to 20. Now, if it was skewed left, that means actually a majority of the data is on the right. So it's going to be mostly on the right. Looks something like this. Yeah, I know. So it's kind of like that. Okay, so that's skewed to the left. So it looks kind of like this. I know it's very crude. Box plots. So if I was going to make a box plot, I'm going to make 3 boxes just the same. Now, if it was median is far over here to the left, and it's got a big long whisker over here, then I would say a majority of the data is right here on the left, so this would be skewed right. And then it would be the exact opposite if it was skewed left, like that. So you can tell the majority of the data is over here on the right-hand side, so that means over here it is skewed to the left. And then normal distribution, so you got about equal size whiskers on both sides, and probably the median somewhere in the middle. That would be that'd be a normal bell curve. So skewed left would be this one right there. All right, so let's get to the lesson now. Be able to compare different data displays. So we're going to first review. So skew, I think we just covered pretty well. We got shape, center, and spread. Spread is how spread apart the data is. Remember, spread is like range or interquartile range, or if there's outliers, where center is like mean, median, and mode. All right, now we're looking at these 6 class sets of data. Miss Smith's class, Lemon's class, Kraft's class, Adam's class. So we're going to compare them, and the first thing you're going to do right here is list some sort of description of each. Now I'll let you write it here because I am trying to keep this video down a little bit, so just watch and I'll basically tell you what you could say. I would say in this case that all the scores in Miss Smith's class are between 0 and 105, so I would write that right here. And a majority of the students got D's and C's. So that's how I would describe this. Here, I mean, it looks like Miss Lemon's class, all the students got either B's, C's, or A's, or low A's. So everybody got between 70 and 85, and it's pretty evenly distributed. If I was going to describe Croft's class, number 3, so I would write that right here. Miss Croft's class, I would say first of all, there's an outlier. And everybody else got either somewhere between 60 and 100, and it's very evenly distributed. Miss or Mr. Adams' class here, I would say everybody got between 60 and 105, and it's more of a bell-shaped curve, but actually there's a lot of people who got A's. So maybe I would say that in my description. So there's a high-level amount of people. In fact, the 3 highest levels are all A's. Well, actually, this is 85 to 90s, but B's are higher. Majority of people got B's or higher. And this one's very normal shaped, normal bell curve between 60 and 100. Not much to say about that. It's very similar to this. We'll talk about differences later on. And Miss Jones' class got an outlier here. And it's a pretty evenly, maybe this is a little bit skewed to the left, so maybe it would look like that. Looks like it's skewed left. A lot of A's. A majority of people got A's from 60 to 100. All right, so that's what I would have written here. Compare data distributions between Adams and Smith's class. Adam is here, and Smith's class is here. Well, when you look at these two, this one looks skewed right. You can see how the tails off to the right. This one is more skewed to the left. So there's a big difference right there. Got a higher Let's see. I would definitely say Adam's class got a higher median, because I'm going to guess that the median's around right here, and I don't know without knowing the actual numbers, but I can tell because if I add up these bars, they would equal to these bars over here on this side. If I was trying to find the median of Smith's class, I would say it's between 70 and 75, because once again, these two bars are about equal to all the other bars on the right-hand side combined, and that's really what a median is. It's the middle number. Question number 5. Smith's class median is at blank. So let's see. Smith's class, just talked about that. It's between 70 and 75. And I also gave my justification as for why. And Lemon's class's median is at, let's see, Lemon's class. So if you look at the data, you can literally count all of these circles and then find the circle that is in the middle. I'm sure when you do, you're going to find it somewhere in this 80 to 85 range. Remember, that is such a small distribution, because the spread is so much smaller than the other classes, that the median, it's fairly easy to find. It's going to be in one of these 3 plots, guaranteed. And it's most likely going to be in the one that's in the middle. Question number 6. Hurlia's class has a median of blank, and while Croft's class has a median of blank. Okay, so we're looking at Hurlia's and Croft's. All right, Hurlia's right here, a median. Well, it's a box plot, so we know this line right here is the median, and that's going to be about 82. And the other class was Croft's, and Croft's median is at about 77. Now, remember earlier I talked about how Croft's and Hurlia's look almost the same. Not because they're both box plots, because that's true, but if you look at the size of the box from here to here, that's called the interquartile range. The IQR for both boxes is about exactly the same. Matter of fact, they're almost in the exact same place. If you look at the whiskers are almost exactly the same size as well. The big difference between these two classes, and I would say Hurlia's did better, which that's probably the second half of this question, and the reason I'm justifying why Hurlia's class did better is because of the median being about 10 points higher. So just because the box is in the same place and the same size doesn't mean that both classes did exactly the same, because that means 25% of the students in Ms. Croft's class is here, which is much lower than the 25% that's up here in Hurlia's class. So due to the fact that the median is higher, it means the students that are in that box most did better than the other class. So these two classes very close together, but like I said, Hurlia's got that higher median. Where did we leave off? So blank for both are similar. The box and the quartiles, basically everything is very similar. Number 7, all 3 classes have blank. So we're looking at Jones, Adams, and Hurlia's. So let's go back. Jones, Adams, and Hurlia's. Okay, it looks like data sets 4, 5, and 6. We are trying to find differences, compare data distributions. So all 3 data classes have blank. Well, it looks like they all have scores from 60 to 100. They're all fairly evenly distributed. Well, this one's definitely evenly distributed. Now, what that basically means is that all 4 quarters of the box plots are all equal in size. The size of this whisker is about the same size as this part of the box, about the same as this part of the box, and the same part as this amount of the whisker. Now, this one has an outlier. That's what makes Jones different. Jones has an outlier and the other 2 don't. And I would say probably Jones is skewed to the left, just like Adams is skewed to the left, but Hurlia's is a normal distribution. Now, between these 2 classes, I would probably say that Jones' class did better. Now, I know what you might be thinking. That outlier is really, really low, but you can't say that a class did worse because of one person. That one outlier might just be one person. Whereas if you look at the rest of the data, you'll notice that the biggest amount of people in Jones' class got between 95 and 100, which is higher than in Adams' class. Now, Adams' class, a majority of their students got between 80 and 95, which is very high. But I would say majority of Jones' class got between 90, 85, and 100, which is slightly a little bit higher. So once again, very similar, just like Croft's and Hurlia's, very similar, but there is that one little difference where you've got the highest here compared to having your highest box here. All right, so that leaves us to the homework. Describe the distribution of the histogram. So we're going to talk about shape, center, and spread again. So the shape, remember the shape is the shape that it makes if you were going to put a curved line on top, and this looks like it's skewed to the right. And the reason why it's skewed to the right is because most of the data, majority of it, is on the left-hand side. Now, if you didn't have this interval right here, it'd be very obvious, but with it, I would say it's less obvious. That's really heavily skewed to the left. Skewed right, but it is skewed to the right because it does have that tail going off to the right. Center. If I was going to find the center, I'm going to erase this. The median. Well, first of all, we can't find the mean. And the reason we can't find the mean is because we don't know what the numbers are. Because this is a histogram. All we know is that this is how many people there were in that interval. Do we know how many each one is? We do not. Because unlike a bar graph, you have intervals that represent the data. So we just know how many are in that 0 to 5 right now. They all could be 1s, they could all be 5s, or they could be a mixture of 0s and 5s. We don't know what the numbers are. So we cannot find the mean. Now what we can do is we can find the median. We can add these numbers up. Now I believe the median is going to be about right here. I'm going to put this line right here. And what we're going to do is add up how many there are on each side. 40 plus 30 makes 70, plus 50 makes 120, plus another 50 makes 170. 60, 90, that'd be 120, 130, 140, 170 over here. So we know the median is about 20. So there's your center. Your center is going to be at 20. That's the median. We also know what the mode is because the mode is going to be this tallest, which is between 20 and 25. Now, once again, like I mentioned before, we don't know exactly what the number is. We just know that the category that it's in, because that's what histogram is. It's a bar graph with categories. And then last but not least, we got our spread. So that would be our IQR. Now, remember, this was our range and our IQR. So our range is anywhere from 50 to 0, so it's got a range of 50. 50 minus 0 is 50. Now, if we want to find IQR, we could do that as well. We could say, well, the lower quartile is around right here. The upper quartile is more like around here. 30 minus 10 is 20. So that would be the upper quartile, and there are no outliers in this case. All right, please give it a like to help you learn something about shape, center, and spread, and subscribe if you haven't done so already. Thanks again for watching. Have a great day.